Hello everyone, it's April 30th. Alright, I think one thing I need to realize is um, it's I don't think it's possible to solve this problem the way that I think, because yesterday we struggled a lot just trying to figure out the logic, but I feel it's just so convoluted. So I feel the likelihood is getting smaller and smaller, but maybe I shouldn't give up, right? We just finish it through, and if it doesn't work, then we will not improve on it. We go to the solution. That's kind of how I think about doing it. Okay, what's this? Maximum number of tasks you can assign. N task, M workers. Each task has a strength requirement stored in a zero-indexed integer array tasks, with the ith task requiring tasks I strength to complete. The strength of each worker is stored in a zero-indexed integer array workers, where the jth worker have workers j strength. Each worker can only be assigned to a single task and must have a strength greater than or equal to the task strength requirement. Each worker can only be assigned to a single task and must have a strength greater than or equal to the task strength. Additionally, have pills, magical pills that will increase workers' strength by strength. You can decide which workers receive the magical pills. However, you may only give each worker at most one magical pills. Given a zero index, we can then return the max number of tasks that can be completed. So if we have a worker that has more strength, is it better for it? It's not necessarily. Not necessarily. Because you can boost a worker so that the worker can take on a very hard task and the remainder can, I can see that possibility. Oh, it's some DP stuff, most likely, I think. And then we have more workers sometimes, right? There's workers, task. Basically, we just say among the workers array, we can pick pills number of workers and then put the strength onto them, right? To boost to basically make them bigger. So the first thing that I can think of is, what if we sort them? Tasks, workers, right? And well, ideally, the worker with a large strength should handle the task with a large requirement, because if you ask the worker with lower strength to do it, then it's not going to be as optimal, right? So like we have a task, we have a bunch of workers. You have the task with the highest strength requirement, and you have a bunch of workers, and the workers have different strength, and you should always have the largest worker to go with the largest task, because then you are being more efficient, because then you have lower strength worker and then they don't have to deal with a bigger task, they can deal with a smaller task. So in this case, we might as well just go from, if we sort them, get the biggest, and of course if we have a biggest task is bigger than the worker plus the strength, then it's not even possible to solve it, right? To do it. But if we can, we'll try it. So this first is pretty straightforward. The second is we can only solve one, and the third Yeah, I think it's all very trivial case. Didn't really give me much things to go with. So 10, 10, 10, and 10, right? So we have 3 pills, okay, and then strength is 10. So this is not possible. So, but this is possible and this is possible. I want to solve it this way. I just want to see a counter example because I don't know what a counter example is going to look like. Like, how's this counter example is going to be? Like, all these bigger ones, we just eliminate, right? We don't even have to worry about them. And now we have the biggest task, which is within range. So now it's a question of whether we want to take on this, right? So we can choose not to take on this. And if we don't take on the most, I mean, it doesn't really matter because the extra strength, right? If you can reach it, then you can always reach it. And we might have multiple people who can reach it. Right? We can have multiple people who can reach it. So, in fact, we shouldn't use the biggest one. We shall use the smallest one that's possible if we want to be more efficient, right? So now we have a strength requirement of 15. So 15 minus 10 is 5, right? So we want to find the one that's closest to 5, and we use that to do it, right? We use that one to do it. And now we'll go on to the next one, and so okay, here's the question. Do we always want to use the extra strength? I mean, the goal is I want to save the big ones, right? I don't want to waste the big ones. So if a smaller one, if a weaker worker can get the job done by taking the pill, then I think it's actually a better deal, because if you go with the stronger one, then you have a lot of strength wasted, right? And then once the big one's done and you have some intermediate task, then we also have intermediate and mediocre workers, and then they cannot solve it. But if we do the other way, we maximize the strength. Okay, maximizing the strength. That doesn't sound too bad. So maybe we can turn this into, I don't know, a mapping. Right, we turn workers into a map, and then it will be unique, and then it will be sorted, right? It will be a sorted map with worker strength, and every time we sort it, we get this, and we'll binary search every single time to see if it's not possible, if it's possible, then we'll get like the lower bound, right? Lower bound or upper bound. So we'll get a bound and we'll use that. Okay, that's kind of like greedy, right? That's greedy. I can think of a scenario that if we don't do this way, then we can fail. But I need to convince myself that this is the best strategy. So we always be more efficient. I feel like that's right. Let's try it. But I need to see, because I forgot. Map, binary sort, upper bound, lower bound. So I forgot how to use it. So we got a map, lower bound. So we get an iterator. The first element in the map whose key is either equal to or greater than the given key. So yes, that is the lower bound. We have the strength, we minus the requirement, we minus the pill, right? And then we get a value. So we need to find something that's bigger. The first key that's bigger than this, right? Okay. Yeah, let's try. I think we have to make directory because this is for May. Hey, we like halfway through. It's actually no, we have not. It's not halfway through. Halfway through is June. We're still pretty far from June. I don't want June to come, so like, cause I still have a lot of work that I haven't finished. Time need to pass slower to allow me to finish my stuff. Alright, so that's not what we want. Alright, this is the one. So basically my idea is greedy. Right. We sort the task, right? Sort the tasks and go from most demanding to least demanding. For each task, we always use the pill, right? Then we can find the minimum strength needed, right, to accomplish the task. Right. Then we look in the workers for the weakest worker whose strength is no smaller than the mean strength. So it'll be something like, I don't know, when login, something like that. Not 100% sure, but it should be close. We need a map of int, right? Int and int. Int is the strength and int is the count, so we call it counter. So for int w of workers, we can say counter w plus plus. Okay, so, and then we also say std sort. I don't know, this doesn't feel right. Is that std sort? Yeah, it is std sort. Tasks dot begin, tasks dot end. Okay. And then we want to know what's the question. Maximum number of tasks. So, okay, interest maximum number of tasks. For int I equal to tasks dot size minus 1, I large equal to 0, and I minus minus. Okay. So for each one, I know the current t is tasks I. So I know it could be negative. It doesn't matter. It doesn't matter. We'll use the same method to deal with all of them. Okay, so we'll say int mean strength required is tasks I minus strength times pills larger than 0. Right? So if pills is larger than 0, I'll minus strength. If it's smaller or equal to 0, then this will be 0. So the minimum strength is a tasks, right? So we can say auto, I believe that is auto. Yeah, auto it shall equal to std, just counter dot lower bound mean strength. Okay. What if it's out of the bound? if all the keys are less than k, returns 0 to the end of the map. If all the keys greater than k, returns 0 to the beginning of the range. Oh yes, yes. If we do a lower bound, right? So we say mean strength requires this, and it would return us. So the only difficulty is if it's to the end. If it's at the end, which means if it is equal to counter dot end, is that how we check? Yes. So if it's equal to the end, then we'll continue. But if it's not equal to the end, that means we find one which is larger or equal to, right? So it's larger or equal to, we can use it first, it second to do it. Because it's larger or equal to, I don't really need to check it itself. All I need is we'll say rest definitely plus plus, and it second. I'm not sure. Huh. I am not sure. Key is it first, and I would say counter key minus minus, and if counter key is equal to 0, counter dot erase this key. Okay, right, and then we use it, right? And if we can't, then we don't use it. So we use it, we do that, and then pills need to minus minus as well. And now to the next one, and we try it again, and we try it again, and then we try it again until we finish trying everything, and we can return rest. All right, let's see. At least we need to check if the default ones will pass. Oh, the first one just failed. Oh, yeah, of course. Of course the first one failed, because you don't as you use this for this. That's not right. Right? That's not right. Damn it. Nope. So what we need to do is, like, it has to be used well. Okay? Has to be used well. So for each task, there will be some that's smaller than it, right? So for each one of them, I need to find the one that's smaller than it. Right, I need to find someone that is smaller than it. Or you can say, I am the biggest, and I minus this, so I get a value. Binary search, I find something, and then to check if that something is bigger than me, or like larger or equal to me, right? That means I don't need to sacrifice. I can just use that So I'll say, so we have the iteration, have the key, right? We have the key, and we shall check, right? We shall check. No, we shall always use it, right? Always use it, and we need to see if, so yeah, we can use this key to do it, right? But whether we need to reduce the pill, that is debatable, right? That is debatable, because I need to see if I can do it without using the pill. Basically here I say if this key, which is a strength, is larger or equal to tasks I, then I don't do the pill. I'll only do it if it's smaller. Okay, so it's kind of another iteration. Let's see if this will pass. Okay, pass everything, the easy case, but I had a feeling that we're gonna have to iterate this through multiple times. Yeah, it's as expected. As expected. Alright, I am now going to spend more time on this, so this is wrong, which is fine. Let's check out the hints. Monotonic Q. Monotonic, greedy in the monotonic. The first k smallest tasks to the worker. The first k, wait, what is k? There ain't no k. Is it possible to assign the first k smallest tasks to the workers? Okay. How can you efficiently try every k? Wait, what the hell is k? I don't think k is even mentioned. Yeah, I don't think we have a k. But I feel like what it's trying to say is, because we want to find the maximum number of tasks, so we can say, okay, let's just assign k tasks. Doesn't matter, like binary search, right? We just assign this, we say we can do this number of tasks. And of course, if the number of tasks is bigger than the people, then we don't do it, right? And then we get smaller, so eventually we'll get to a value. We say, okay, let's see if we can fit that many of tasks. And then we do the smallest of them. Yes, we do the smallest of them. Then we can use, are you saying we use this scheme for the smallest of them? So these are the smallest tasks, right? Basically, we just say for the k smallest tasks, is it possible to get it done? Not very sure, but k smallest tasks. K smallest tasks. Yeah, we just get k of them, and then we want to see if it's possible to get it done in on time. And now we have all the workers. And the hints also includes a monotonic Q. How does the monotonic Q play into this? monotonic queue. Yeah, let's say if it's a monotonic increasing, and then we have smaller coming in. That's not gonna help because I already sorted. Yeah, I already sorted, so it doesn't really work that way. Oh, we're definitely not using a map, I feel, in that case. Yeah, we just like two sorted arrays and then see if it's possible. You know, you add something to it and then it can work and get at least k out. Of course, the k is gonna be the smallest, right? How are we making sure if we can get those k out? It's monotonic. It's increasing and the other is also increasing. Is it possible? If this is very big and this is very small, or you know, both are small. Or we can, like, you know, we want to make use of the smallest, so we always add it to the small and see. Yeah, because like we say the smallest k, so everyone has to be accounted for, right? We have to go through every single one. All right, so everyone has to be counted for, and we can find the k largest in the worker as well. So now we have k and k, right? We have k and k. So I have k smallest tasks, and then k biggest workers. Right now, we actually have a one-to-one map, right? We have one-to-one map, and can we just go through them one by one and see if it's possible, right? If there's something that's not possible, we'll get the pill involved, because if at a certain position, right, at a certain position as we go, the worker cannot do it, right? If a worker can do every one, then that's good, but at a certain position a worker cannot do it, right? And I need help. If with help we still cannot do this, then this worker basically can't do anything, because everybody to the left of him has already finished their tasks, right? This actually might work. This actually might work. So this is not working, and this is a fail. Didn't work. But we are going to do another one. Alright, on this, I'll say this is inspired. This is hint. This is this solution is inspired by the hint. We will use binary search, right? At each iteration, we want to see if we can accomplish, right? Accomplish k tasks. If we can, we continue searching the upper half, otherwise the lower half. Now, given k tasks, we want to use the least demanding k tasks and the strongest k workers, right? And if any of course, both tasks and workers have been sorted, and in this one-to-one, right, mapping, if any worker cannot succeed even after pills, after taking into account the pills, it is not possible. Alright, so no map, no nothing. We basically sort this and then sort workers, and in fact, I wonder if this is the best way. Sort, yes, I just sort them. Right, tasks, not tasks. Workers dot begin, workers dot end. Alright, so now we have this, result shall be not result, we have a low, high. Low is 1, well actually 0, because it could be more possible. High shall be task.size.
Oh.
Alright, so how low, smaller than high. Int mid shall equal to low plus high minus low divided by 2. Alright, so now we just want to know if it's possible to get mid. To do that, we'll take the smallest tasks and the biggest workers. Right, biggest workers. And to do so, I also need, say, m equal to tasks dot size, n equal to, in fact, I want to swap this. I want the workers dot size, and I want tasks dot size. Okay, so here is going to be n plus 1. Now, we are going to say for pills int remaining, pills remaining shall equal to pills. Okay, and for int I 0 I smaller than mid, right, I plus plus. Tasks, we can just use I, right? If workers something is smaller than tasks I, and how do I know we go through everything? That's a good question. Therefore, I think I0, and then we'll do smaller than mid and pills remaining is larger equal to 0. Okay. While so workers is smaller than task, and because pills remaining is larger or equal to 0, see, this is a little bit slippery. Let's just do this. So if this, right? If pills remaining is equal to 0, so we cannot break, right? We cannot help you anymore because you're not as strong, and this is going to be workers. So I basically take the last k. So if I take last 2, minus 1, minus 2, so it should be minus k. Not minus k. Dear me. Shall be, because I is gonna be here, so this shall be minus mid plus I. Right? Minus mid plus I. So if mid is 3, minus 1 minus 1 minus 3 plus I is 0, so this is gonna be that. Okay. So yeah, so if we don't have enough pills, that's a break. If we do have enough pills, and now we say if workers n minus, I kind of don't want to write again, but I guess it's fine. If it is plus strength, it's still smaller than tasks I. Tasks I. If that's the case, then we'll break again. This is like if you add the strength, but still not possible. Right, okay, now is if we add a strength, it is possible, so we'll say pills remaining will be minus, okay? Yeah, so basically this is good, then we'll move on, we just go I plus plus. Now, why do we even do it this way? Right, now it looks like I can say for int I equal to 0, I smaller than mid I plus plus. Right, I don't even need to do this one. So each time we just check. So I just keep going, and then whenever it breaks out, oh, that's why. Because when it break out, well, it's fine. We will just do this. Right? We'll put the I on the outside, and then we'll do this, blah, 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 blah. And then if everybody's happy, right? If everybody's happy, then when it gets out, I shall equal to mid. Otherwise, I is still smaller than mid. All right, there's one thing that I need to consider, because if I don't have enough workers, right? So if mid is the number of tasks is bigger than the number of workers, then it's not possible. So immediately it's too big, right? It's too big. So high shall equal to mid, and then continue. Right, not enough workers. High equal to mid, now we just continue. We'll try it again. If it's good, then we'll do blah blah blah, do this. It goes through every single one. And when we get out, we'll say if I is smaller than mid, successful. right? This is successful, successful. Now, if it's successful, that we can fill all this, then we can try to get a bigger one. So say low equal to mid plus 1, right? Else if it's larger or equal to, that's when we say high equal to mid. All right. So we do this, right? We keep doing this. So low will be plus 1 because it's possible with plus 1. And then that's when it ends, right? It's not possible. Then we get out. Then I return, because plus 1, low plus 1 is not. Yeah. Like the mid is possible, but mid plus 1 is not possible, so return low minus 1. Okay, let's take a crack at this one. Well, easy case first, make sure that everything still works. And it does not freaking work. The answer is -1. Oof, that is neither here nor there. Okay, so what went wrong? I sort them, okay. And then low is 0, which is nothing, right? High is n is 3, high is 4, so 0 and 4. So 0 and 4. Huh. Low is 0, high is 4. 4 divided by 2. So mid is 2. Right, mid is 2. 2 is larger than m, no. So pills is still 1. So 2. No, I smaller than 2. So workers is m is 3. 3 minus 2 plus 1 is 3 minus 2 is 1. 1 plus 1. 1 plus I is 1. 1, yeah, so basically is pointing here. And task is 0. Right? So if I think I got it mixed up. I smaller, that is bad. I smaller is bad, which means I haven't gone through the whole thing. This is high equal to mid. This is bad. This should be low equal to mid plus 1. This is good. Then we go for the next one. There we go. That looks more promising, and we are going to use this test case. So I run it one more time. Oof. I cannot believe it. I thought this was right. I really thought this was right. So basically, what we say is we find output 100. Huh. Because we have 1-to-1 mapping, right? So we say worker is the strongest of them. Tasks are the lowest of them. So we do a 1-by-1-to-1 mapping, right? So if the worker is smaller, then I need help. But if I don't have any pills remaining, then yeah, we can't. Or if the worker plus the strength is still not enough, then that's also not possible. But if it plus strength it becomes possible, then I have used up a pill. So it could be a situation where every single one requires, but like if they are already too big, you're too small, how can we even change? I don't know, because we have to cover everyone. Alright, we probably can, I don't know, alright, I am going to do some very crude debugging by print out. So what type of mid have we gone through? 99, 149, 124, 112. 112 is not possible. That is bonkers. 112. Huh. Yeah, this one's right. $112. I don't know, just trying stuff. What? Tasks is n. Oh, but I want the workers. Huh? No, 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 no. Oh, plus I. My bad. Alright, now we can take a look at the first 100. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 and 10. Yeah, okay. What's the strength? 2208. think this means we used up. Wait, hold on a second. 99. $87. Yeah, I have no idea. Only 87. I guess we used up the. Actually, I'm not sure. How many pills remaining? 0. So I used up the pills already. But that's already as strong as the workers. It is the weakest the task and the strongest the workers. I think this is the first one. 3175. This is 3270. So I could have used the next one to do it. So if everything is shifted just a little bit, right? Like the worker's strength is just slightly smaller. Slightly. But the next worker's strength is actually bigger. So So what are you saying? What I'm saying is, as we go through the tasks, once we hit one that the current cannot do, we'll try to find the next. We'll find the first that it can do, and the current will just add it. And push it back into the queue because the current just cannot work. So this is like a priority queue. It's like a priority queue, right? It's just, we check the smallest powered worker and then we say, are you good? If you're not, if you're good, we move on. But if you're not good, then I will move to the next one. So if it's good, then I'll move to the next one. So this one can get out, put into another one, right? And then maybe a priority queue. Maybe a priority queue. But man, priority queue, this may make me take too long. Yeah, but you just have something that doesn't work, right? If it does not work, priority queue. What is priority queue? It's a max queue, right? Yeah, I remember it's a max queue. Yeah. But we'll do the negative. Okay, if q, what should I say, int work shall be q dot top if, and then q dot pop, if w is larger or equal to the task. Maybe I can even do int task of tasks. Oh, actually no, because I only do the first. So if it's larger or equal to, then we just move on to the next one. So if this is smaller than tasks I, now here it depends. If we don't have pills anymore, then yeah, so we say if pills remaining is equal to 0, then we just break. Otherwise, we say q dot push minus w plus strength pills remaining minus minus. I see. Right. Pop. If it's smaller than this, if it's 0, then we break. Otherwise, I pop it and I push it back, but with a different strength. Right? And then this into minus minus. And we'll continue. Right, I plus plus, and then blah 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 to the end. And then this, I remember, if it's smaller, that means it hasn't finished, so it's too bad, it's bad. So high equal to mid. This should be low equal to mid plus 1. Alright, this is my last shot. If this one is still no good, then we are not going to keep doing it today. But I need to do my Spanish first. The Spanish shouldn't take too long. Just, conjugation. I do conjugation every day because these things are easy to forget, and need to constantly drill them. And also I need to be fast, right? Like, the ideal is I don't even have to think. I see it, and then I know what the conjugation is. Okay, done. Alright, conjugation done, and then we can test. Try. This one work. Oh, this one works. So we basically have log n on the outside, on is here, and I have another, call it on log n. So inside is unlog n, outside the log n, so it will be log n squared. Right, log n squared. When checking, we want to use the least. Yeah. When checking whether it is possible, right, for the k strongest workers to finish the k least demanding tasks, we use a priority queue to always surface the currently smallest, currently weakest worker, right? If this worker cannot handle the currently least demanding task, it requires a pill, right? It requires a pill and push and gets and goes back to the priority queue. That's basically what this is. All right, I'm gonna check on all of them. So we know test case is one pass, reset test case. I'm gonna try to see the easy case, whether they will work. Oh my lord, it don't. What in the world? Holy crap. My answer is 3. Ugh. I don't even know where to start. Okay, low is 0, high is 4, right? So now I have 2. We start with 2, and the lowest is these 2, highest is these 2. Okay, and then we do 3. We do 3. So we have these 3, and then we have these 3. Right, so I smaller than mid. Yes. And then 10 and this is good. I plus plus. And then 10. W worker is smaller, yes. Pills, we have pills. So we basically 20 when we push it in. And then we check again. Right, I didn't move because I continue. So I check again. Now it's 10 again. Oh, you cannot use it more than once. Holy crap. How do I... Oh, man. How do I keep track that... So you're telling me it has to be a pair. I can't just use an integer. Well, we can be a little ingenious. I can't because it's 10 to the 9th. I was thinking about adding another one towards the end to indicate whether it has been fulfilled or not. But I guess it's not that straightforward. I guess we have to use pair. If not using pair, then this, how do you prevent the same one from getting incremented more than once? Right? How? Well, we can. No, we cannot. Because there's no indices. Unless we do indices, then we have to write a separate function for priority queue. Implementation details. I don't. Oh, priority queue. But then you have to use a separate. Let's just go pair. Okay, so I'm gonna push number of times, right? So 0 times. So strength, number of time, has pill, taken pill, has taken pill, right? So have not taken pill. And then this is fine. We shall say auto p is this, okay, and this is minus p dot. Is dot or I do not know. I honestly do not know. Is pop? Okay, let me guess. It's p dot first. If it's smaller, and if this, yes, and otherwise we're gonna add. But if it's smaller than 0, and it has been added already, yeah, or p dot second, right? So it has already either no more pill, or we have already, or the worker has already taken the pill, but still the strength is not enough, and that's break. Otherwise we'll do minus p dot first plus strength, take a minus, yes, and we'll do a 1, right? We'll do a 1, and we do that. All right, let's see if this one is right. Okay, all these pass. Go back to this one. We'll try one more time. All right, everything pass. Submit. Now the only thing that worry is timeout. Oh my god. It's not just timeout, this is wrong. All right, I'm not doing this anymore. Editorial. Copy and paste, and then we'll deal with this some other time. Wow, 2 of them wrong. That's unprecedented. This is a copy and paste. to study this at another time. Alright, I'll submit this, but this is definitely not. I mean, this one is wrong. I am very surprised. This is wrong. Again. I'm very surprised. I thought this is enough. Priority queue is enough. Man, it's not enough. Oh, wait, hold on. I need to use the previous solution. Why binaries? Why priority queue still not enough? That's, I don't know. Why priority queue still not enough, right? I am already saying that if it's not fitting, I will basically give him a pill and then let him wait. Like, what more do you want? Right? What more do you want? I mean, we can say that we need to, because the next one may be too large and you don't want to use it on this one, right? Maybe it's too large, but everything is sorted. If everything is sorted, then if next one's too large, everybody else will be too large. All right, this one is I don't know. I really don't know. No clue. Anyway, that will be it. This is pretty tough. I thought we were there, but we're not. All right, I'll see you guys tomorrow. Adios.